So my name is Puneet Kapoor. I will be taking your data structure and algorithm course. So I am starting this course new on the YouTube, and I will be covering most of the basic and important concepts which are asked in your competitive examinations, job interviews and gate preparation. Right? First basic concept in algorithm and data structures or in data structures is arrays. Right? So we will be starting with arrays, right? And there are pointers concept also involved. So I will be starting with very basics, how we declare in a variable in C programming, and in later on lectures I will be giving you what you say programs also, running programs. So say if I write int a 10, right? If I write like this, right? So int means the type of data, a is name of array, and 10 is size of array. So this is the basic declaration of array in C programming, right? In some other programming language, like syntax will be bit different, but the logic will be same. So I will be explaining that in this course. Say if you write like this, if you store a 10 and you say take 10 values, 2, 5, 1, 3, 8, 12, 19, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. These 10 values, right? So how the memory will be allocated in the programming language, right? In fact, this is the basic declaration in C. This is how we declare it in C programming. So first of all, when you write like this, so message goes to compiler that this is the name of array, this is the size of array. Here we declare size of array, right? And the compiler gives the memory manager, right? The person who is managing the memory in the system, right? It may be operating system, right? Or usually it is memory manager. We will take memory manager name for now, right? Later on I will tell you what it is exactly. So it will give you memory chunk like this: 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? And 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So if we count from 0 to 9, these are 10 memory blocks, right? So index of array starts with 0, right? In means it, why it starts from 0, that also I will cover, right, once we move further in the arrays. And the main concept in array is the memory has been allocated continuously. So continuous memory allocation is there. We will be studying some data structure, in those memory will not be continuous or it need not be continuous, right? Like linked list, right? But for arrays, memory is allocated continuously, right? And say in memory storage, say this block is at address say 4000, right? Now it depends on size of integer in your system. Earlier the system use, when you use you can check it with size of function in C program. If you check size of integer, so in old systems it was 2 bytes, in some of new systems it is 4 bytes, right? So I will take this example with 2 bytes, 2 byte of memory, right? If it is 4 byte, then the next block will be 4004, but since I am taking it for 2 bytes, so next block will be 4002. So this memory size will be 4002, then next block will be 4004, then it will be 6, 8, 10, 12, 14, 16, and 18, right? Means 4018, right? So from 4000 till 4018, right? It has taken the memory size. Fine. Means every box, yeah, every block which has been allocated to the memory will take 2 bytes of data, because size of integer I am taking as 2 bytes, right? So in old systems, or in not very new systems, it is 2 bytes only. Nowadays it is 4 bytes. So if this memory has been allocated with 4 bytes, then the next address, 4 bytes for int, right? So next address will be 4004, 4008, and so on. I think I have made my point clear here, right? So memory has been assigned continuously. So this is a way in which the array has been declared, and these values will be assigned like this. So 2 will be stored here, 2, 5, 1, 3, 8, 12, 19, 11, 22, 23, right? It is continuous chunk of data, right? So since it is continuous, that's how we can access any element of the array by writing this. If I write a of 2, right? So when we write name of array, actually in computer it gives you base address of array. Write a2, right, with index 2, right? So the name of array always gives the base address of array, right? So it will get evaluated like something like this. A will give the base address, that is 4000. 2 is location, right? So it will be evaluated like 2 multiplied by 2, means here 2 is size of int, right? So address of this location will be calculated like this. If you are writing a of 4, right? So it will be taking a, you take as base address 4000, and this 4 multiplied by size of 2, right? So see, this will be 4004, right? This memory location it is saying, and this will be 4008. See, and that's how we like sometime we casually write a of 4, this is 4004, right? And a of 2 is 4 to cat, right? 4008. A of 4 is 4008, you see here, and a of 2 is 4004 here, right? 4004, right? So this memory means when you access it like this, right? So it will give you value as a of 4004, that is 1, right? So here it will be like, it will be using a pointer address, right? Since I have written pointer here, so I will be introducing pointers also to clearly explain you. So this will be value add. For now you say it as value add 4008. What is the value at 4008? That is 8. In here it is 8. What was the value at 4004? It was 1, right? So this is how it is being calculated. So the basic data structure which is called array, it will give you continuous memory allocation. So to understand this further, I need to explain the concept of pointers, because I told you this, right? This is base address, this is size of array, and this is like the unit, right? Means you are the unit which you are calling, right? So you are getting this as 1. Then I told you this will give you address, exact address, and when you are writing this, so this pointer I introduced. So what is pointer actually? So pointer basically is like when we write simply int a, right? So I will just quickly introduce you to pointers, right? We will be doing more calculations for pointers also in subsequent lectures. So this is very good way to explain actually the pointers with the help of arrays, actually how it is being interpreted in arrays. So say when you are writing int star p, right? So this actually gives information to compiler, like we are pointing to something, we have declared a pointer which will be pointing to something, right? So it should be pointing to something in memory, right? Obviously in memory, right? So if you have written a separate statement int a equal to 5, right? So how it goes, some memory location say 6000, that has been assigned a name a, and 5 goes inside it, right? Now when you do star int star p, it this thing has to refer something in the memory, right? So that something will be a variable, right? Or basically a memory address, right? So if I want to make this pointer point to some location, what I will do, p equal to and of a, means assign and is written for address, right? So assign this address of a to this pointer p, right? So what it will do internally, it will point to this memory location actually. So when you do point p is as and of a, so it will basically point p to this location, means p is having an address. So what pointer stores, basically pointer stores basically an address, right? So when you are doing p is equal to and of a, it's directly taking the address. Now come for arrays here. So when you are writing a of 2, right? So it is basically is being evaluated like this, star base address. So for this example it is 4000, 2 is the index multiplied by the size, right? Right. So when I evaluate, now when I have pointed in here, so when I evaluate it, so it will be star 4000 of 4. So this is star means value at 4004, right? So in array, this thing, the thing which I have told you below, is being evaluated like this, right? When you are writing a name with index, it is being evaluated like pointer, right? And basic pointer is like this. We will be talking a lot about pointers in subsequent lectures, right? So I hope I have made you clear what are the pointers, right? For array, if we say array name, it will give you the base address. This is the key line which we have to remember. in arrays in arrays, if we say array name, it will give base address, right? Now you know, if we have base address, right, then by doing this star, right, then only we can access that value, right? So for time being, I will be like stopping the pointer thing here, and I will be moving forward with arrays, right? And then I will be taking separate lecture for pointers itself, right? To make you explain how this is being accessed, that so first hint I have given, this is being accessed by pointer, right? And pointers take addresses, right? So this is like a of 2, so go to that address and give me that value. So this is how it is being evaluated, right? So this is very basic structure of array, right? I think it should be clear to all of you who are watching. Now I will give you the funda of address also. Say if someone says, say I am taking another array, say I am declaring a array name x, right? X of 5, right? And I am assigning 2, 4, 6, 9 and 10, right? This is how continuous memory chunk 1, 2, 3, 4. So say this time I will give you index as 1, right? To make you understand the importance of index as 0, that's why I'm writing 1, 2, 3, 4, 5, right? And the memory 2, 4, 6, 9, 10, right? This is the name, or say it is at 2000 address, so it will be at 2002. I am taking size as 2 bytes only. 2004, 6 and 8, right? Now if you want to check the location of x of 4, right? So there is a basic formula which is being evaluated inside here, right? The way I have told you, right? Now I am converting this thing into a formula actually, right? So how it is being checked, right? So say I am saying give me location of x of 2, right? X of 2, right? You can write with brackets also. So how I will get? I will take base address, right? That is 2000. Then x of 2, right? Now you see how it is being calculated. It is like when you are taking x of 2, no? So this will be 2 minus 1, means the place from where we have started. So this will not be visible if I take every array with 0 index. That's why I am taking this as example. Multiplied by size of int, right? If it was char here, character array, so I have taken integer array. Okay? So I just write a line, consider an integer array and integer. Consider an integer array below, right? So size of int for this case, right? Now it will be 2000 plus 2 minus 1, that is 1, and size of int is 2. So 2002 will give us exact address, right? This is how it is being calculated, right? So if your array has been started, I will take one more example, right? Say my array starting index is starting from, I will write it parallelly here. Say if I have declared array, say alpha named, right? Or okay, take alpha 5, right? And I am giving 4, 3, 2, 1, 0 as values in it, and its base index, right? The alpha is name and 1, 2, 3, 4, and values are 4, 3, 2, 1, 0, and starting index is starting from say 25, 25, then 26, 27, 28, 29, and alpha's base index address is say 2000. So it will be 2, 4, 6 and 8, right? Now if someone writes a of 26, right? So why I'm showing you this, because I'm going towards one formula actually, how it is being calculated. So in this case, if I say location of alpha 2, right? So what I will write, base address 2000, right? Now it will be like alpha 2 26, right? So what I have to write, 26 minus the point from where it started, 25 multiplied by size of, if it is integer, as it is understood, size of int, right? So it will be 2000 and plus size of int is 2 and 2002. So now I think I have made the formula also clear. So the basic formula is base address plus last location. Last location means the point. So I will not write it as last location. I will write here as xi. So location of xi, base address plus I minus start address, right? start index base address, ith index, which index we are, and start index multiplied by size of, right, data type. Actually, this is the basic formula which internally is being calculated, right, to give you the location, address of the value, right? So size of the data type, ith index position, and minus start index, that I have made clear also in here also, right? The start index is important. So this is how we calculate the location of linear array. Now when we write xi, so this pointer thing will come into the picture, which I have already told you, right? We will be looking at this in detail, but first we should understand how linear arrays is being evaluated. So see, I have taken this example. If start index is from 25, so I have to write 25 here to get proper values, right? So now I will give you answer why. Sometimes students ask me why index starts with 0 in arrays. So now I think it is quite obvious also. We are not making the offset. This is called offset also, right? Offset thing quite complicated. So that's why we are taking it as with 0. Now, say this same example, right? This same example, if I write it here, so alpha, and if I take the values of alpha 4, 3, 2, 1 and 0, and it is 2000, and if I start it with 0, 0, 1, 2, 3, 4. So to calculate location of, so I will zoom out here. So to calculate location of alpha 2 in this case, or say right clicks alpha 2 index, it will be base address, right? That is 2000 plus, now you see 2 index value minus 0 means we don't have to write offset value again and again. That's why, to make things easier for users itself, size of data structure, right? So that's why the index starts from 0, because we don't want to make this as a calculation in itself, right? So that's how it is being evaluated very nicely. So this was the point which would not have come if I have not changed the addresses, right? So this is the basic way to get the addresses, linear location addresses of arrays, right? So in next lecture I will be starting with the 2D arrays and how it is being stored, and after 2D arrays I will move more towards the pointer, right? So till then, bye bye, right? And I will add the pointers in detail, pointers lectures more. Thank you for listening me. Bye.